Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to discuss about logistic regression problem. What exactly is logistic regression? And we are going to discuss on this part. And in my upcoming video, I am going to show you the practical implementation of logistic regression as well. So before moving on, I recommend all of you to connect with me on LinkedIn as well as on Instagram, and I will leave the link in the description box. So when you talk about logistic regression, right, we have to understand that, especially in the linear regression, I'll start from the linear regression itself, that in linear regression, our main goal was to have a best fit line, right? Our whole goal was to have this y is equals to mx plus c, right? And we always had a continuous output in case of linear regression. But when you talk about logistic regression, in logistic regression you only have a classification problem. So when I say a classification problem, in fact in my very first video on machine learning, I described the different types of machine learning and the subcategories, right? So logistic regression is nothing but it is a classification problem where you classify the data, right, 1 or 0. Right? In linear regression, it is a continuous problem, right? For a particular weight, what can be the possible height, or for a possible height, what can be the possible weight, right? That kind of a problem is solved using linear regression. But when you talk about logistic, right, you kind of describe that, okay, this is a spam email or not, yes or no. So that kind of output is called as a classification output. So logistic regression comes in that. Now, it cannot be solved the way we solve the linear regression problem, right? So for example, when we talk about the linear regression, right, what do we do? So we kind of try to get the best fit line. It can pass from here or it can pass from here. This is the best fit line that we kind of get in case of linear regression, right? But when you talk about logistic regression, now let's say your output, let's say this is the output y, right, and this is your x input, right? Now let's say this is the linear regression line that we have. Now in this linear regression line, in fact, let me draw it a bit neatly. So if you see, this is my x-axis or my input variable, and let's say this is my y, which is my output variable. Now if I draw this particular line, right, I can call this line as my y is equals to mx plus c. But now let's say I have my classification problem, right? Let's say I have my logistic regression problem where I want to classify whether I have a spam email or not, right? If a email is a spam email, let's say I call it as 1, and if it is not a spam email, right, if it is not a spam email, then let's say I classify it as 0. Right now in case I have to plot this using this y equals to mx plus c, it will be really difficult, right? Because for, let's say, for whenever I have 0, right, then I will have basically my points over here. Let's say for every value of x, I will have my points here. But let's say when I have a spam email, let's say my y is 1 over here, right, and then all my points will actually come over here, right, and it doesn't fit this particular line. So even if I have a one outlier, so let's say I get any one outlier in my data set, then in that case what will happen is my linear regression line will try to twist. The moment it tries to twist or it tries to create a new linear regression line, I will again not be able to fit my other points, right? And similarly, y equals to mx plus c can also have the negative values, right? It can also give me the negative values for y, right? But in case of logistic regression, your output is either supposed to be 1 or it is supposed to be 0, right? You can solve it, you can say that, okay, I can say that whenever the value is negative, whenever I have the negative values for y, I can mark it as 0. You can say that, but it doesn't work out when you try to actually solve it using y is equals to mx plus c. So in that case, basically for logistic regression, right, we use a completely different formula, if I would say in that way. So logistic regression, if you see right over here, as I said, it is a binary classification. It is used to solve binary classification or multi-class classification problem. So when I say binary classification, whenever your output is 2, right, it is 1 or 0. In case of multi-class classification, let's say that you have more than 2 outputs to predict. Basically, in that case, it is called multi-class classification. Now, in this case of logistic regression, right, it is you use something called a sigmoid function to fit the curve, right? So just now I told you 0 and 1 output, right? You cannot use simply y is equals to mx plus c line. Now for that part, you actually use something called a sigmoid function, which you can also see on the screen, which will actually fit this particular curve. It will fit the curve like this, what you see on the screen right now, right? Now if the value, let's say it is greater than 0.5, right, over here in the middle, we call it as 1, and if it is less than 0.5, we call it as 0. So if you see the sigmoid function fx, it is 1 divided by 1 plus e to the power minus x. Now this is your sigmoid function, which you actually use for the logistic regression. Now what is this x over here? This x is nothing but it is y is equals to mx plus c. It is the same linear regression line, y equals to mx plus c. Your x is exactly that. That is why logistic regression is also called as generalized linear model for predicting probability of an instance belonging to a particular class or category. So it is a generalized linear model, right? And we use sigmoid function over here. Now if you look at this, right, if you look at this blue line, right, that is nothing but a linear model line, right? This is nothing but y is equals to mx plus c, or y is equals to theta 0 plus theta 1x, or y is equals to beta 0 plus beta 1x. So basically, you can use different annotations to represent it. But now if you look at the logistic model line, this orange model line, right, and now you look at this particular sigmoid formula, p is equals to, now p is the output value, 1 by 1 plus e to the power minus beta 0 plus beta 1 x, which is nothing but your y is equals to mx plus c. Now this is what your logistic model is all about, right? And even the curve that you see, right, it is not a straight line curve. The orange curve basically represents your logistic model. So I hope you understand this particular part. And now moving ahead, basically in the linear regression, we discussed about the cost function, right? So basically in the linear regression, we already discussed, right? Now if there are any values, let's say you have let's say this is your linear regression, right? Now here, let's say these are the output values, right, the actual values. Now the difference between these actual values and your predicted values would be this, right? Now we wanted to minimize it, correct? Now to do that, what we created eventually in the linear regression, we created the cost function, and our basic idea was to minimize the cost function, right? Now in the similar way, even for logistic regression, you have this as the cost function. Now you can actually see over here, right, this is the value, this is the whole cost function that you have. If you want me to show you how you can actually derive this particular function, you can let me know. I can create a separate video for it. Now it is pretty long, right, and so I can't keep it in this particular video, but if you guys are interested, then do let me know in the comment section. I will create a separate video for it. So now if you can actually see that minus y log h theta of x minus 1 minus y log 1 minus h theta of x. H theta of x, you already know it is coming from your linear regression. You would have watched my videos on the linear regression already, so you would already know about it. Now if you see this cost function, in case y is equals to 1, if y is equals to 1, now you can see that this particular part will become 0 and your only value will be log h theta of x negative, right? Now if your y is equals to 0, then your first part will become 0 and your second part will eventually become minus log 1 minus h theta of x, right? Now if you see this particular part, the whole idea in logistic regression is to minimize this particular cost function, and you can actually see the curve as well over here, that Now this curve is almost equal to the gradient descent curve, right, that you see in the linear regression. So even in the linear regression, if you remember, right, that we discussed that in the linear regression, the cost function, when you try to plot the cost function, it looks like this, right? Now if you see over here, right, now when the value of y is equals to 1, you can actually see your gradient descent curve, which is nothing but the plot of your cost function, right? It looks like this. Now if you combine both of them, it actually looks like your U-shaped curve itself. So this is the cost function for your logistic regression model as well. So I hope you liked this particular video. You understood the whole part of why do we use logistic regression, what is the whole purpose of it. And thank you so much for being till here. Do remember to like, share and subscribe to my channel. Thank you so much.